11B, we're going to look at a chi-squared test for independence. So we have two variables that we're going to look at, and we're going to test to see whether or not they are independent. Okay, so example, a researcher wants to see if gender influences adults' favorite way to eat ice cream. Okay, so the table below shows the preferences of 2,200 adults. At alpha is 0.01. Can you conclude that the adults' favorite ways to eat ice cream are related to gender? Okay, so basically we're testing to see, like, is there an actual difference here between males and females in terms of how many people picked each way to eat ice cream? All right, so our steps, first, as always, identify the hypotheses, okay? And so for this one, the null hypothesis is going to be that the variables are independent, and the alternative hypothesis is going to be that the variables are dependent. All right, find the totals and expected frequencies. So in this table, the reason I left these spaces over here is we are going to find the totals. All right, and so as simple as it sounds, like we're just going to add up all of these numbers to find the total for each row, and then we're going to add the numbers down and find the total for each column. Okay, so I'm going to do that right now. Why don't you pause, and that way we can come and check that we have the right answer. So this is what I got for totals. Okay, so adding across the row, adding down each column, just like two-way tables back when we did probability, the way that you can check your work is that this grand total right here should be the same if I add down here. So 1,200 plus 1,000 is 2,200. And then if I add these numbers across, they also add up to 2,200. And that should match our sample size. Okay, so we're good there. We have our totals. All right, and then expected frequencies. So what we're going to do actually is I'm going to pull up the calculator here first. Okay, let me go back to, okay, so we're going to be in the regular calculator. All right, and what we're going to do is go to the matrices. All right, so something you probably have never used on your calculator. All right, so it's right here at the bottom, so I'm going to press F1. And then I get this whole big list. So a matrix is basically a table. So we're organizing the table. Okay. And so I'm going to press enter here to edit this. And it asks me for dimensions. Okay. Dimensions are rows times columns. Okay, so for M, I would put the number of rows that I want, and for N, I would put the number of columns that I want. We're not going to include the totals. So if I go back and look at this table, not including the totals, I have 2 rows that have numbers in them, and I have 1, 2, 3, 4, 5 columns. Okay, so 2 rows, male and female, 5 columns. I'm not including the totals. All right, so my matrix needs to be 2 by 4. All right, and press enter a couple times. And so now what I have here should match the table. Okay, and so what I'm going to do in this first matrix is I'm just going to enter the numbers, again, not including the totals. Okay, so 600. All right, and if you just press execute or enter in between, it'll move over for you. 288, 204, 24. Oh, whoops, I miscounted. Well, I didn't miscount. I put the wrong number. Hopefully you guys caught that. All right, so if I mess up, I'm going to go back and press dimensions. All right, I don't want 2 by 4. I want 2 by 5. Okay, so now I'm going to put these numbers in again. All right, 600, 288. 204, 24, 84. Press enter. It takes me down to row 2, 410, 340, 180, 20, and 50. Okay, so again, only the data points, not the totals. Okay, so now I press exit, and I'm going to go down to matrix B. All right, I want that to have the same dimensions, so 2 by 5. Okay, and in here, we're going to put expected values. Okay, and so what we're going to do is we're going to do some math that if we assumed that these variables were independent, okay, and that they were randomly put in these categories, all right, what would that look like if it was totally random? Okay, and so here's the math that we're going to do. For each little space, we're going to do the row total times the column total divided by the sample size. Okay, So for the first space in my matrix, for the 600, the expected value there is going to be the row total, so 1200, times the column total down here, okay, the row and column that 600 are in. So the row total is 1200, the column total is 1010, and then I'm going to divide that by the sample size or the grand total of 2200. Okay, and so that is my expected value. Okay, and then the next one. So for 288, my row, it's still in the 1200 row. Row total times column total of 628 divided by the grand total of 2200. All right, and so we're going to continue that process. Sorry, my dog's angry with me. We're going to continue that process for every square. So what I want you to do is pause here, okay? And I want you to continue doing this for everything else and then come back and we'll see if we have the right numbers. So here is my calculator screen and the numbers that I got, okay? So I'm going to scroll through a little bit so you can check. These are the numbers that you should have got for each expected value. Again, doing row total times column total divided by grand total, okay? And so that is my matrix B. Okay, so we've completed up to step 5. Now step 6, we have to go back to all the other, where we did all of the other tests. So I'm going to press menu and go to stat, okay, and then it's test, chi-squared, okay, and then here, again, this is where my calculator is a little bit different for you. You will have to pick F2 for two-way because you have choices between goodness of fit and two-way. Once you pick two-way, your screen should look like this. And this is exactly what we did. We did the observed in matrix A, the expected in matrix B. I'm going to press execute. All right. All right. And so there's my p-value, 1.42 times 10 to the negative 6. So remember that would be 5 zeros. We generally round p-values to 3 decimal places. So I'm going to say that p is equal to 0. All right. Because there would be 5 zeros after that decimal point. All right. Then for your conclusion, it's the same as what we've been doing. All right. Alpha was 0.01. All right. So P is less than alpha. So we reject the null hypothesis. Okay. And that means that we have evidence to say that the variables are dependent, or in the case of this problem, you have evidence to say that adults' favorite way to eat ice cream is influenced by gender.